Okay, we're ready. So we've got some fractions, and when you see a fraction in algebra, really we don't like fractions. Anyone tell me how you can get rid of a fraction? No? What you do to get rid of a fraction is you multiply it by its denominator. So for example, take the fraction half, and if you multiply half by 2, write it down, if you multiply half by 2, yeah, essentially it's 2 over 1 because 2 is 2 over 1. What happens is the 2's cancel. So if you multiply by a denominator, it gets rid of the fraction, which is a good thing. Okay, so whenever you see fractions in algebra, multiply everything by its denominator. For example, in this one, we're going to multiply by what? What are we going to multiply by? 5, okay? Now, you will know that because of my seesaw imagery or metaphor, the seesaw has to stay in balance, so as long as you do the same thing to both sides, the seesaw balances. So multiply 5 by both sides. Now that's brilliant because when you multiply the left hand side by 5, the denominator cancels, it disappears with that 5. So the left hand side now reads 2x, right? And the right hand side reads 5 over 8. Or I could write it like this, 5 times 1 over 8, which is the equivalent of 5 over 8. Right, I've got another fraction there, which is 1 over 8. There's a couple of ways of doing this, but again, as long as you do the same thing to both sides, you can do anything you like, really. I'm going to get rid of the 8 by multiplying both sides by 8. Okay? Left hand side by 8, right hand side by 8. Both sides. 2 times 8? 16. And then on the right hand side, what happens? The 8 cancels and I'm left with 5. Okay, because what happened on this over here was 8, I multiplied it by 8, so the 8's are gone. 8 divided by 8 is 1, 5 times 1 is 5. Okay? And then we get a very simple problem. 16 times something gives 5. To undo times, we use division. Divide both sides by 16. Again, I'm doing the same thing to both sides. So my seesaw is in balance. And therefore, x is equal to 5 over 16. In algebra, we leave things as simple fractions as we can. We don't actually take the calculator and go 5 divided by 16 and then round. We leave things as a fraction, and if you can simplify the fraction, do so. 5 over 16, can we simplify that? Do you know anything that goes into 5 and into 16? No. So 5 over 16 is my answer. My next example is from page 54, and I'm going to look at question 4, where there's x on both sides. X over 2 has to equal 2x over 3. We don't like fractions. How do we get rid of them? Times by the bottom number or the denominator. And it doesn't matter if I do it 2 first or 3 first, as long as I do them. I could, in fact, when you get good at it, you can do it both at the same time. Not for my example, but I'm going to do it separately so people can follow my working. You could do this at the same time if you like. So times both sides by 2, gets rid of the denominator on the left hand side. This right hand side has to be times by 2. So I can either write it like this, 2 multiplied by 2x over 3, or I could write it 4x over 3. So, hey, look at that. I've almost, I was going to say got x by itself, but there are x's on both sides of the equation. So the principle when there's x's on both sides is to try and collect them on the same side. Keep going with the fraction thing. I don't like fractions. Okay? To undo that 3 on the denominator, I multiply by 3 on both sides. Left hand side will read 3x, right hand side will read 4x. That's an unusual looking equation. 3x equals 4x. Without even carrying on at the moment, what's the answer going to be? What number do we have to give x to make those two things equal? If I gave it 1, 3 times 1 and 4 times 1, it would say 3 equals 4. Is that true? No. The only number that you can give x is 0, because 0 does equal 0. But if I didn't see that straight away, remember the principle is to try and collect x's on the same side. There are more on the right hand side, so I'm going to subtract from the left hand side. We'll collect so I'm subtracting 3 from both sides. 3 minus 3. What's 3 minus 3? 0. 3x minus 3x is 0. 4x minus 3x is 1x. And hey, I ended up at the same answer as we thought. X equals 0.